So in this graph, the voltage of the inside of the cell as the action potential occurs. It starts out at resting potential, which is negative 70 millivolts. Then it reaches the threshold potential around here at negative 55 millivolts. Then the sodium channels open and sodium enters the cell, which brings the voltage up to around 40 millivolts. Then the sodium channels close and the potassium channels open, which bring the potential back down and eventually below negative 70 millivolts. And once the potassium channels close again, it reaches resting potential once again at negative 70.
This is at resting potential, so it's polarized right now. And the stimulus reaches threshold potential. So the sodium channels open. So sodium enters the cell and becomes depolarized. And then the sodium channels close and the potassium channels open, repolarizing the axon, which resets the gradient. And then in the undershoot, the potassium channels close slowly, and then everything resets.
Okay, so this is like a cross section of the axon, and so these are the two channels, sodium and potassium. And so for action potential, the sodium opens and letting sodium enter the axon, and then when the inside of the cell reaches 40 millivolts, then the sodium closes and then the potassium opens, releasing potassium outside the cell, and then then that will decrease the voltage, and then like it'll undershoot for a bit, and then the channel will eventually close slowly, and then to help like create the charge again, the pump pumps out 3 sodiums and into potassium with every ATP. Synapse. So here. Dendrite. So this is. Oh crap. Synapse. This is the synapse, and then these neurotransmitters, they move over here to bind with the membrane, and then they release the neurotransmitters, which bind to receptors on the postsynaptic cell, which starts another action potential down the cell later.
This is a presynaptic cell.
Yeah, and this is a presynaptic cell. And this is post. Right?
So Schwann cells, they insulate the axon for the signal to help pass through the nodes of Ranvier, which boosts the signal faster to get the message just moving along the neuron very fast.